Welcome to myprojectbazaar.com. Let us see the project title. The title of the project is Lightweight Location Verification Algorithms for Wireless Sensor Network. Let us see the abstract of the project. The abstract: localization in wireless sensor network, that is, knowing the location of the sensor nodes, is very important in many applications such as environment monitoring, target tracking, and geographical routing. Since wireless sensor networks may be deployed in hostile environments, sensor locations is subject to the many malicious attacks. For example, attacks can compromise sensors, inject false location information. They can also interrupt signal transmission between the sensors and contaminate distance measurements. Hence, the location estimated in the location process are not always correct. Although some secure algorithms are proposed to help the enhance sensors' resistance to attacks, they cannot completely eliminate wrong location estimations. Therefore, we consider location verification as a necessary second line of defense against malicious attacks, which becomes the focus of this proposed system. We can classify the previous location verification algorithms into two categories. They are namely on-spot verification and in-region verification. On-spot verification is to verify whether a sensor true node location is the same as its estimated location. Most existing verification algorithms belongs to this category. To obtain the desired on-spot verification results, these algorithms can either utilize the deployment knowledge of the sensors in the field or make use some dedicated hardware to verify the distance measure. Then another system, it is assumed that some convert base stations are deployed throughout the field. These special base stations communicate with the another through wired links and purposely hide their existence from the being discovered by sensors. Then these base stations can verify sensors locations by checking whether the distances calculated using sensors estimated locations are same as the distance they directly measure the using RF signals. In the existing system, it is required that the sensors are able to measure the time in nanoseconds in order to detect the range reductions that directly impact the location results. Since existing verification algorithms either require deployment knowledge or depend on the hardware that are expensive and generally unavailable in low-cost wireless sensor systems, a lightweight verification algorithm should be designed that can effectively perform on-spot verifications. The proposed system is designed for a verification system that overcomes the shortcomings of previous research. The verification system can effectively verify whether sensors or estimated locations are trustable. According to the specific requirements, the system can provide either on or in-region verification results. First, to provide on-spot verification service, two algorithms can be used by the proposed system. They are namely the greedy filtering matrix algorithm and the greedy filtering trustability indicator algorithm. Both algorithms exploit inconsistency between sensors, estimated locations, and their neighborhood observations. Second, to perform in-region verification, a verification region is first calculated according to the application's functions. Then a probabilistic algorithm is used to compute the confidence that a sensor is inside the verification region. All the algorithms proposed in the system are lightweight because they do not require any hardware infrastructure and they do not incur high computation overhead at the sensor side. So the verification system can be applied to low-cost wireless sensor networks. Let us see the data flow diagram of a project. At first, the data owner. So here the data owner collects the basic information of the network. The basic information contains the network informations like packet transfer rate and network speed, and likewise all the network information should be collected. So the collecting of the information is done here because we can know that how many packets should be sent according to the network speed. Next, then the packet formatting. Here the details which are going to send to the host node should be collected first. In the wireless sensor network, the data are sent according to the packets. So the packet information contains the header and payload. The header represents the source and destination information, and then the payload represents the data. Here the data collected is the infrastructure details because here we are going to transfer the infrastructure details from the sensor. So the sensor collected information will be the temperature details or any other weather important details. Then the packet generation. Here the packet generation. So all the collected details are gathered to form a packet. A packet that may contain many data useful to the host node. So next, the two type of verification. The one is the on-spot verification and the second one is the in-region verification. In the on-spot verification, the sensor is checked whether it is on the place which has been placed by the data owner. Otherwise, if the spot is changed, then the measurement details should be transferred to the host node. And the second type is in-region verification. We should check whether the sensor node is in the region that can communicate with the host node. Otherwise, it is not in the region, then the host node cannot be connected to the sensor network. So the data transfer and communication will be lost for the network. For that on-spot verification, we can use the greedy filtering using matrix algorithm. Then for the in-region verification, we can use the continuous distribution and discrete distribution. So finally, the in-region verification is done. If the node cannot be communicated, then a node should be contain some problem. So we should rectify that. And the on-spot verification can be done only for to know the node is on the space. So when it is misplaced, then we should rectify the problem. So we should place the node on the correct spot. Let us see the demo of the project. At first, we should click the next button. Here, when we click the initialize network, it will show the node deploy symbol. So we should click the deployment. Here, the randomly 10 nodes are created. The nodes names are namely A, B, C, D till J. Here, the node place and the region of the node also displayed. Then when we click this button, it will show the connectivity among the nodes. Here, the connectivity may show the many nodes are connected with many nodes. Then when we click this button, it will show the network routing calculation. Here the node deployment, here the number of nodes deployed is displayed. Then we should click the next button. When we click this button, it will show the network status. So here the data owner should connect the basic information of the current network, that is the network type, signal status, network speed and the coverage strength, data identification. So these informations are very useful for the data transformation. The data owner can now decide whether how many packets can send to this network. Then we should click this button. It will show the signal irregularity. Then we should click this button. Here we should click the check node variation. Here the node redeployment may needed. The deployment of the nodes has been shown here. Then it will need a further deployment, so we should take the OK. Then we should click the next button. Here we should click the click to analyze the variation button. Here the node deployment is shown and at the same time the nodes which are misplaced has been shown. Here the misplaced nodes are shown in the white color. So when we click the next button, it will show the click to analyze. Here the node which are misplaced are shown and the misplaced position, that is the distance, is calculated. So here the distance is calculated according to the axis in the region. So here the on-spot verification is done and the in-region verification also done. Here the node's current position, Y position and X position also has been shown. Then the old position of the XY has been shown. So using this position variation, we can calculate the misplaced position, that is the distance between the misplaced position and the current position is calculated. The next button, so it will show the network status. So when we click the start monitoring, it will show the network status in the graph. When we click the network sampling bitrate, it will show the network sampling bitrate, that is what is the bitrate of the network sampling is shown here. Then we should click the OK. When we click the network sampling rate, here the network sampling rate also shown. We should click OK. Then we should click the next button. Here the source and destination allocation and service organization is shown here. So the source and destination allocation represents the region distance of the source and destination. So the region of the source and destination is shown here. When we click the view data, we'll view the data, that is the services in the 4 services are shown here. Then if the packet is received, we can get the acknowledgement and also the packet sent range has been shown here. Then we should click the transmission range. So now what is the transmission range for a node is shown here. We should click OK and then we should click the next button. It will show the graph. So in the graph, it will show the network value for the current data transmission. When we click the next button, it will show the connecting time to the network is displayed. Then we should click the next button. It will show the next network cost. Thank you.